So this one's a combination of right-hand rules 1 and 3. For right-hand rule 1, I'm using that to find the magnetic field produced by the wire. I'm going to use blue to draw that. Okay, so I'll stick my thumb, my hitchhiker thumb, to the right and visualize my fingers wrapping around that wire. They will end up coming out of the page on this side. And wrap around and go into the page on the other side. Now, I'm just drawing some of the magnetic field. It's going to fill the entire space. However, it's going to be stronger, closer to the wire, a bit weaker, farther away from the wire. But all I really need is the direction of this magnetic field. So that's part 1. And now that we know the direction of the magnetic field created by this wire in the area of these charged particles that are moving, now we'll use right-hand rule number 3 to determine the force. So I will go with yellow, I suppose. So now use right-hand rule 3 to determine the direction of the magnetic force on each moving charge. Emphasize the word moving. If these charges were still, there would be no magnetic force. Okay, so right-hand rule 3. I'm going to start with the positive charges because the right-hand rule is designed for positive charges. So I'll call this number 1 here, and I'll start with number 1. So my index finger needs to point in the direction of the velocity, which is to the right. And now my middle finger, this is tough, got to twist. My middle finger's got to point in the direction of the magnetic field, which is out of the page. And when I do that, I end up having my thumb pointing down. So charge number 1 is going to feel a force down. Charge number 2. Actually 2. I'll just label this one number 2 down at the bottom right here. Same thing. Index finger needs to point in the direction of the velocity. So I got my index finger pointing up. Middle finger has got to point in the direction of the magnetic field, which is into the page. I drew that in blue. And now my thumb sticks out at a 90-degree angle to both of my other fingers. And right now it's pointing left. So this charge is going to feel a force to the left. Okay, I predict that charge number 3, I'm going to go to the one above it. I predict that that's also going to be the left. I haven't checked with my right-hand rule yet, but I think it'll be the exact same direction as charge number 2 because there's 2 reversals here. So my charge went from, it's negative, charge 3 is negative, whereas charge 2 is positive, so that's one reversal. Secondly, the magnetic field reversed. So charge 2 had a magnetic field that was into the page, charge 3 has a magnetic field out of the page. So those 2 reversals kind of cancel each other out, and I should get the same direction for my force. I'm going to quickly double check with my right hand though. So I'm going to have my index finger pointing down because it's a negative charge. The velocity has to be the opposite direction. And I get my middle finger pointing out of the page. And yes, my thumb is pointing to the left, so that was correct. All right, second, and then my very last charge. I'm gonna predict it goes up. So I'm gonna relate this to charge number 1. I'm going to relate this to charge number 1. So charge number 1, I got an answer of down. So I think charge number 4, I'm going to have an answer of up. Because of 3 reversals. Instead of a positive charge, it's a negative charge, so that's 1 reversal. Instead of moving to the right, it's moving to the left. So that's the 2nd reversal. And the magnetic field, it's out of the page for charge 1, it's into the page for charge 4. So that's the 3rd reversal. So 3 reversals simplify down to the answer should be in the opposite direction. But I will double check with my right hand. So I'll get my index finger pointing right. Because it's a negative charge, it needs to be in the opposite direction. I've got my middle finger pointing into the page because that's the magnetic field on charge number 4. And my thumb has to stick out, and it's sticking out upwards. So that is correct.